All right, today we are going to cover the last section that we're covering in Chapter 2 before our test coming up, and that is solving compound inequalities. So compound means more than one. And so in a compound inequality, normally we're used to seeing something like this. Say where x is greater than or equal to 2, and something like this where x is less than 5. So a compound inequality is we're going to combine both of those things together into one inequality. And so if, and this is key, if x is greater than or equal to 2 and less than 5, we can write it all together like this. You notice how x, it's like sandwiched in between the 2 and the 5. It's greater than or equal to 2, if we read it backwards there, and it's also less than 5. And what that looks like graphically is this right here. You can see the line is in between the 2 and the 5. The 2 is filled in, right? And a solid point there on 2 because it is or equal to, but then on the 5 it's open circle because it's not equal to 5. So if it's an and, it's the intersection, right? It's all the points that fulfill both inequalities, greater than or equal to 2 and less than 5 at the same time. Where the other one is the or. And that is, or means it's everything. It could be either. It's this or that. It can be either one. So we include all of it. So here we have y less than or equal to -2. Here's y is greater than 1. If y is less than or equal to 2 or greater than 1, all of that is the possibility. So we include all or everything, where this one over here is the overlap. So let's write and graph some compound inequalities. So a number x is greater than -8 and less than or equal to 4. So this is going to be the sandwich. It is greater than -8 and less than or equal to 4. So that's what that would look like. If we graphed it, we would have our -8, our 4, open, closed. There we go. Now this next one is an or. So this means it's most likely going to look like this, going in both directions. A number y is at most 0, So y is less than or equal to 0. At the most 0, it could be less than or equal to. Or at least at the smallest, in other words, y is greater than or equal to 3/2. So this one, when we graph it, again with the or, it's usually in both directions. So we have 0, and then here's 3/2, and that's what that looks like. So again, in general, if you have and, it's going to look like the sandwich. If you have or, in other words, it's going to be like in between, right? If you have the or, then it's going to be going in two directions. So let's see. A number D is more than 0, so D is greater than 0, and, oh, I'm going to just back that up then, since it's an and. So it's like 0, D is greater than 0, and less than 10. 0, 10, both open. or. So A is fewer than, less than -6, or not less than, so greater than or equal to -3. So when we graph this one, -6, less than, -3, there we go. Now we're going to solve some compound inequalities with and. So remember the and is we have the sandwich. And to solve it, we need to get x by itself. So we want to get rid of that -2. So we do want to add 2. And since these compound inequalities have 3 parts to them, 3 sections, whatever you do to one section, you have to do to all sections. So that's what this is going to look like. And we have -2 less than x less than 5. So now we have x by itself. I'm going to put in my -2 and my 5. And it's the sandwich. Same thing here. So we're going to subtract 1 from all 3 parts. And we get -4 less than -2x less than or equal to 8. But now we need to divide by -2. And when we divide by a negative, remember we have to flip the inequality. So this is a tricky one. This is a tricky one. So all these inequalities are going, oh my goodness, what just happened? There we go. All these inequalities are going to flip. So this is going to be 2x -4, or we could rewrite it -4x 2. This one makes a little more sense because it's in the right order. Because -4 is on the left, 2 is on the right, and it is still the sandwich. Now with or, when it's or, we know our final graph is going to look like this. So it is really like a two-parter. We solve one, then we solve the other. So we're just going to add 5 to both sides. 3y less than -3. Divide everything by 3. So 1 is y is less than -1. Or, and now we solve the other one. 2y greater than 6. Divide by 2. Y greater than 3. So we go to graph this. -1 less than 3 greater than. All right, so now let's have you try these. We're going to do all of them. Pause the video and then hit play once you've solved them to check. All right, this first one. For this one, we're going to subtract 4 from all sides, all parts. 1 less than or equal to m less than 6. 1, 6. There we go. Number 6. Oh my goodness, I can't write. We're going to add 5 to all parts. 2 less than 2/3 k less than 5. Now we're going to multiply each part times 3/2 times 3/2 times 3/2. Here we're going to get 3k. This is 15/2. If you want to call it 7.5, you could do that. 3 15/2. There we go. Oh, we got some more space here. So 7 looks like 4c plus 3 less than or equal to -5, or c minus 8 greater than -1. All right, so to solve this, we're going to do each piece here. C less than or equal to -2, or C is greater than 7. So if we graph that, -2, 7, there we go. And finally, 8 looks like 2p plus 1 less than -4, or 3 minus 8p less than or equal to -1. All right, so -1, 2p less than -5, 2p less than -5 halves, or -2.5. And then, or -3, -8p less than or equal to -4. Dividing both sides by -8. Don't forget, greater than or equal to, oops, and this is 1/2. So when we graph, -5 halves, 1/2, and there we go.